Alright, good morning. Almost lost my computer there. I'm doing too many things on there at once. My load average is spiked. It's over 10 right now. So hopefully this doesn't get like super laggy or anything. And I'm muted. Alright, good morning. My laptop is borderline about to explode. So let me know if this gets like super laggy or something. And I'll stop some stuff that's going. But I've been running a job on my laptop for about 5 weeks now. I started it September 23rd, and it's been running ever since. And it's about 60% CPU bound, so it's got about 2.5 weeks of CPU time. So I'm hoping I don't have to reboot my machine. Although Zoom just popped up a notice saying my CPU usage is high. So that can't be good. Let me share my screen. Alright. So I am planning to finish talking about the midterm, talk about programming practice problem options, talk about ODP 409 that you just finished, and then talk about ODP 450, which was posted this morning. Any questions before we jump into all of that? All right, well, let's start with the midterm then. So we were up to question 4 yesterday, and I'm not going to spend too much more time on this. Like I say, if you have particular questions, you can always come to office hours and hit me up there. But let's run through the rest of this. So question 4 was looking at a bash script to read a number from the user and then print out all numbers from 0 up through that, and if the number is negative, don't print anything. And this is doable with something like this. So you're supposed to prompt the user, I believe, and then read a number, and then we want to print out all the numbers from 0 up to that. Well, you could do something like, I equals 0, while I is less than or equal to num, do echo I equals I plus 1, and done. So if the number you read in is negative, this while loop never executes and you don't print out anything. If the number you enter is 0, this will execute once. When I is 0, it'll print out a 0 and you're done. If I is 5, it will loop for I equals 0, 1, 2, 3, 4, and including 5, and it will print out each of those values. So that would do what the question asked. But there's lots of ways to do this. Issues that that I saw in people's solutions, doing your while loops or doing your if statements differently from how it was described in class and how it was posted on Canvas, that costs you points, okay, which I told you it would. Exiting your loop too soon, if you do like a less than num, you may miss the last number. If you do your increment before your echo, you may miss the first number. If you echo outside of your loop, you may end up echoing a 0 even if the input number was negative, which shouldn't happen. If you didn't have a loop of some sort in here, then you're not going to get that behavior of printing all the numbers. If you don't initialize your variables, you get undesired behavior, things like that. So, and by and large, you know, if there's little details missing like that, it's not a big deal. Other than, you know, my insistence that you follow the syntax for whiles and ifs and conditionals and doing arithmetic. But the bigger concern is if you know you had no idea how to start this, or if a solution that you see doesn't make sense to you or something like that, then that's stuff that you should work on more, and we can talk one-on-one on how one might do that. Question 5 was ask the user for a number and then print out twice its value or 3 times its value based on its sign, and do this until the number that's entered is a 0 and then exit. So the morning section I did this with one style of loop. Let me do this in a different style here, which is to use an infinite loop. I don't like infinite loops as much as I like what I'll call clean loops, where you actually exit the loop based on some condition. But just to give you a different presentation, let's do this with an infinite loop. So put your shebang. And you can put almost anything in here. But if you put the word true in there, don't think that that's actually looking at true and treating it as a Boolean value and deciding that it's true. I could put the word false in here and it will still loop forever, right? So make sure that you understand why what you're doing works, not just, you know, get something to work. So this is really clearly a Boolean expression, right, which will always evaluate to true as long as 1 is equal to 1, which it will be for the remainder of the course. So this is a true infinite loop, while 1 equals 1 do. So, and I believe we're supposed to prompt the user. You ask the user for a number, so put out a prompt, read a number. Alright, if the number is equal to 0, then, well, I could break out of the while loop, I could exit out of the entire function, I could shut down the entire machine, whatever you want to do to get out of this behavior. I'll just do a break. Alright, if in fact your number was positive, so if num is greater than 0, then we want to print out 2 times the number. So $paren num times 2, else echo 3 times the number. And that's the end of my if statement, and there's the end of my while, and that's the end of my whole program. Alright, and a lot of different things you could do here, right? I could have made this an else if, but I don't need to, because if this if statement is true, I'm never going to get here. I'm going to break out of my loop right there. And if I can minimize how many things I'm putting inside other things, or how much I compound my if statements, right, my code's going to be simpler for me to follow. So if the number is 0, I'll break. If the number is positive, I'll print twice it. Otherwise, it's got to be negative, because it's not 0, it's not positive. I'll print 3 times that number. And then I'll come back up to the top, print a prompt, get a number, and so on. Alright, other ways you could have done it as well. So issues I saw on that, and most people did pretty well on this question relative to the other questions. You know, the usual comments about syntax errors for whiles and ifs. Make sure that if you want the value of a variable, you say $variable. If you want to assign a value to a variable, just say variable equals. Don't say $ variable equals, because that evaluates this and replaces it with whatever the value of the variable is, which is usually not what you're after. But variable equals, but then if you're using this on the right hand side, use a $ to evaluate the value of a variable. Let's see what else. Not printing anything. A few people squared and cubed their numbers instead of multiplying by 2 or 3, which was interesting. I didn't take off for that. You had to be checking to see if something was positive or negative. It's really easy to do things like, you know, if you do this check at the end, you may accidentally print 2 times 0 or 3 times 0. You might exit too soon, you might exit too late. Just details on getting the logic nailed down. But didn't see a whole lot of sort of very concerning systemic issues there. And then the last questions, not a lot of issues there from people. Just some Unixy things. So make a directory named work, that's just mkdir space work. And then change in that directory, that's just cd space work. Right? If you just say make dir work, it will be a directory under your current directory. That's how we usually create subdirectories to start projects in and stuff. If you said make dir /work, that were created under the / directory. If you said make dir /home/nic/work, it'll make exactly that directory. So relative paths are relative to your current location. Compile main.c to create an executable, gcc-o program main.c, or a gcc main.c-o program. And pretty much everybody got that. List the files in your directory, ls. Add main.c to the staging area, git add main.c. Commit it to the repository, git commit. And then some people did the git push origin master to also push it over to the GitLab repository. That's fine, but I didn't need that. Make a copy of main called main2.c. That's the cp command. cp main.c main2.c. I don't think anybody reversed those, which is awesome, because if you reverse them, you potentially clobber your file main.c. So it's source and then destination. All right, and as I say, if you have questions about, you know, why it took off points on a problem, or, you know, your particular answers or something like that, definitely come by office hours. We can talk about it. But any questions about this that people want to ask right now, this is a good time to do it. Otherwise, I'll close the book on the midterm. All right, cool. Let's go on to comments I was making about ways to practice and get better, and I just want to mention one site that I touched on yesterday. It's called W3 Resource. I don't know anything about them other than I stumbled across it a couple of years ago, and I've pointed some students there, and it seems to work. But I'll post the link to this page in the chat. For people who are interested. It's practice problems, right? So this is the page for practice problems in C, and they start with, you know, basic declarations, and they go all the way up through recursion and files and sorting and linked lists and things like that. If you're wanting to get more practice in C, I think this is a decent place to look for sample problems and snoop around. Okay, so if you go to basic declarations, the first few questions are pretty straightforward. Write a C program to print your name, date of birth, and phone number. Okay, well, pretty straightforward, except you have to know how to edit, you have to know how to compile, you have to know how to execute. And if you miss a semicolon, you have to know how to go back into your editor and find that, and so on. So this is, you know, a kind of good getting up to speed thing. We haven't talked about how to get the version of C you're using. So number 2 right off the bat is like, you know, not something we've covered. But the rest of these, right, print letters in giant fonts using number signs. You know, it's a bunch of print statements, but it's practice at writing print statements. And so these get, you know, more and more interesting. Convert specified number of days into years, weeks, and days, right? This is a good exercise. This is modular arithmetic. And it says ignore leap years. Why do we ignore leap years? Well, think about that. And if you didn't want to ignore leap years, how would you do that? Or in fact, how can you write a program that tells you whether a given year is a leap year? Because it's not just divisibility by 4, it's weird rules, right? So practice problems, right? I've mentioned yesterday, best way to get better at coding is by doing more coding. But there's always this question, what should I be coding? What should I write? Well, if you don't have projects in mind or things that you want to explore, sites like this offer you hundreds of practice problems, and they start from, you know, things that are using sort of fundamental concepts, and they build from there. So these are declarations. You can get into basic algorithms. So I don't know, find the larger value from 2 positive integer values in the range 20 to 30, or return 0 if neither is in that range. Right? We don't need a lot of complex data structures. We don't need a lot of complex looping here, but you got to be able to take an input, parse it, do some conditional comparisons, and take this written statement and turn it into, you know, something that can be coded. So it's about algorithms as well as actually writing C code. And these do get, you know, somewhat increasingly difficult. It's not strictly increasing order, but write a C program to create a new array after replacing all of the values 5 with 0, shifting all zeros to the right direction. I don't even know what that means, but if you read it a few more times, you'll figure it out. And there's an example of what it should do, right? And for all of these, you can click through to see the solution, but don't do that, because once you see the solution, that problem is ruined for you for life. You can never go back and do this problem on your own, right? So really struggle with these, and if you can't do a problem, make a note of it and work on some other problems and then come back to it, right? This is you know, calisthenics for programming. If you can't lift the, you know, 40-pound barbell, getting somebody to lift it for you doesn't help you lift it the next time, right? Well, it does if they're spotting you and you're stressing your muscles and playing with those edges, but you know, the goal is not to write a program that does what this says here in 72. The goal is to be able to write that program. So play around with these, if you like, and they get into all kinds of things beyond what we'll be doing in this course. Some of the pointer stuff, definitely the linked list stuff and the recursion. And there's other sites like this out there also. Find one that works for you if you like, and play around with it. All right, let me make a comment about homework 6, which came up in an email. So I revised the assignment a while ago. Under Git repository, it says your repository should include a README, a makefile, your source files, and nothing else. Okay, and that was confusing to some people who wanted to have a git ignore file. So when you make a Git repository, you always have a directory named .git. And if you want to ignore certain files in your project, you can make a .git ignore file, and so on. So when I said include a makefile, a README, your source files, and nothing else, right, I didn't mean you can't have these files in your directory, right? Those are always going to be in your Git repository, at least this directory. So I modified the assignment to say, you know, you can include those, but you don't have to do anything to include those. So don't try to git add.git or anything like that, right? Just don't worry about these, right? They're hidden, which means we don't see them, usually means we don't have to think about them. Okay, so don't worry about, including or excluding .get or .get ignore or anything like that. Just ignore them, okay? But if I say ls, I want to see your makefile, your readme, your .c's, your .h's, and that's it. Okay. Yeah, I suspect people's videos are lagging. Let me see where I am. It will get better. Let me close out a few more things. Let's see. All right, I will shut this down. I can't. All right, I think the lag will improve in about 7 minutes. All right, so that was all I want to say about homework 6. Let's talk about ODP 409. So ODP 409 was just like ODP 408, except we were doing extra error checking. We were allowing various forms of illegal or missing arguments. And we went through and we wrote a flow chart which suggested, the steps in which to check different things, and the order in which you do those things was significant, right? In particular, see if the argument is negative, right? Well, you can't do that unless you know that the argument is a number so that you can compare it to 0. See if the argument is a double precision number. Well, you can't do that unless you know that there is an argument to check, right? So really the first thing you want to do is make sure you have an argument. And then if you have an argument, run it through scanf to see if it's a double. And then if it's a double, compare it to 0 to see if it's negative, right? And so it had to be in that order. And so here was my solution to this, right? And it's really just, kind of a straightforward translation of that flowchart from yesterday into code. So first thing, check argc, make sure it's 2. That's how you know you have exactly one command line argument. If argc is not 2, print an error message and exit. Okay, argc must be 2 if we get down here. Otherwise, we would have exited. So since argc is 2, we are safe looking at argv bracket 1. If we don't do that check first, segfault. All right, so now we can check argv bracket 1. We can scan it, save the scanned value into X, and throw extra stuff into extra, and make sure it returns 1. If it doesn't return 1, our argument was present but not valid. We'll just print a message and exit. Now we're at the third part of our test. Argument was present, argument wasn't a valid float. Let's see if it's negative. If it's less than 0, print an error and exit. Now we've gotten through all 3 of our steps. Argument was present, argument was a float, argument was not negative. We can compute the square root. So there's the ODP 408 code. Calculate the square root, print it, and you're done. Alright, so I think that most people figured this out in the end. So let's take a look at the new ODP. So ODP 450, this is about string processing. This is going to be our next topic for a few days. And your goal is to write a function that takes a string argument and removes all occurrences of an uppercase X from that string. So let's say you're this function named clean, and you receive the argument hexalexon. What you want to do is remove the x's from this so that when you come back from the function call, your string would look like that. So there's no return value from the function. It's declared to be void, but it will change this string that's passed to it. Now normally when you pass an argument to a function, if you pass an int to a function and you change that int inside the function, it has no effect on the thing that called it. But with strings, since they're pointers, since they're arrays, if we change the string inside our function, when we get back to our main program, that string will be changed. Alright, we'll play with some code for that in a second. Let's talk about the algorithm for doing this first. So our goal is to remove all the uppercase X's to basically turn this string into that string. And this is where I think it's useful to think, how would I do this as, you know, a person? If someone came up to me and handed me this string and said, hey, I'll give you a quarter if you remove all the X's from that string for me, what would we do? Well, we would write this down and we'd hand it back to them and we get our quarter, right? But how do we do that? How do we write this string like this without any X's in there? And let me tell you what you don't do, probably. This is probably not what most of us would do. We would say, okay, let's keep the H, let's keep the E, there's an X, let's remove the X. So I'll get rid of that. Well, now I've got a space in my word, so I'm going to move my A down there, and I'm going to move my L, and I'm going to move my E, and I'm going to move my X, and then I'm going to move my O, and I'm going to move my N. And where was I? I had just done the E. Okay, I'll do the A, I'll do the L, I'll do the E. I'll skip the X, so I'm going to get rid of that. And there's a space, so I'll move the O down, and I'll move the N down. And then I was at the E, so there's the O. Okay, and there you go, you're done. Right? That's not the way that we would normally do that. You can do that in code, and sometimes there's a reason to do that, but that's way too much work for an ODP. So here's a different way to do this, and this is, I think, the way that we would do this as humans. We would simply start with the first letter in our input string, and we would, you know, start with an empty output string, and we say H, we want that. So we'd write an H down. And there's an E, we want the E. And there's an X, we don't want the X. There's an A, we want the A. We'll take the L, we'll take the E, we'll skip the X, we'll take the O, we'll take the N. There's our output. Yeah, I don't know what I'd do if someone actually offered me a quarter to do this. Alright. And you know, we don't do it that explicitly, but when you're trying to come up with an algorithm for something, you kind of have to step beside yourself and watch what happens when you solve the problem yourself. What steps are taking place. And there's usually a lot going on. And in this case in particular, you know, I had something which was going through my letters one by one. And I also, you know, was using my pen to keep track of where I was going to write the next letter. So I just wrote the N and I moved my pen over here, and if there was another letter here I wanted to keep, I would write it right here and I'd move over. And that really kind of informs how we would write an algorithm to do this in something like C. So let's sketch this out a little bit. So I'll just call my argument arg, right, for argument. So what do we do basically for each character in our argument? If the character is not the letter X, copy to some sort of output area. Well, for us, we can just write down next to the letters we've already written, but we're really going to need something that keeps track of where we're going to write this. So let's make an output loc and set that equal to 0. So we're going to copy to output bracket output location, and then we're going to increment output location. That's going to get us most of the way there. So what is output? It's a character array, so let's declare that. And here is where I made life a little easier on you. Actually, a lot easier. Which is in the README, it tells you that you may assume the incoming string is not null, so it actually points to characters, but also it has no more than 120 characters. Alright, so because we know that it's never going to have more than 120 characters, we know that this output area never has to be bigger than 120 characters. If there's no x's here, we'll copy the whole thing to here, but if there's x's, this is going to be smaller than our original string. So I can declare this temporary variable to be 120, and that should be fine. Alright, so basically start an output location at 0, and anytime we find a character in our input that's not an x, copy to the next location in our output and bump up that output location. So we have two pointers going on here, right? We have one which is marching through the input, and we have another which is marching through the output, and they're not the same value. If we hit a string of x's, we'll keep marching through the input, the output pointer will stay fixed. And then when we get to something that's not an x, we'll copy that over and bump up the output location. Alright, two more things we have to do after this. Number one, we have to terminate the string. So terminate the output array. Because remember, a proper string has to have a null terminator. Well, we didn't need it here, but in practice, if we were doing this to hand to, something in C, we would need to write a null terminator at the end. Well, output location starts off at 0. When I finish writing the n, output location is going to be here. Output location is, what is it in my mind? It's the location where I'm going to write the next character. There's different ways to do that. I could set it to be the location where I wrote the last character that I wrote. I'm thinking of it as where the next character is going to get written. In which case, I can add the null terminator with something like this. Alright, that's the location where the next character should be written. I'll write a null terminator there. The other possibility or, right, loop over each character in the argument, including the null terminator. If I do that, then this code in here will look at the null terminator. It's not an X. It'll copy it to my output. Alright, so how do we loop over characters in a string? Here's a typical way. Right, so good old for loop. Start off with an iterator equal to 0. Loop as long as that's less than the string length of arg I++. This will loop over every character up to, but not including the null terminator. Remember, the null terminator is at arg bracket string length arg. That was the stuff we played with the other day. So if we loop as long as I is less than that, we will go up to and including the last character, but not the null terminator. But in this case, if we don't want to add the terminator at the end, we could simply change this for loop and say for I less than or equal to, and put a comment saying that includes the null terminator. Either way, you can do both. It's overkill. But you've got to have a terminator in your output at the end, otherwise you're going to seg fault. All right, and one more thing we got to do here, we're supposed to change this argument itself. This is where we can use string copy. So string copy argument output. So string copy is a string.h function that basically takes this string and copies it into that string. So all of this is building an output string, right? It's building up this thing. And then the string copy basically takes this and copies it over there so that it rewrites it on the piece of paper that we were handed to begin with. And then in our main program, when it looks at the piece of paper that was used to call clean, it'll be the original word with the X's removed. Alright, questions about that? I want to write some code next and play around with passing strings, but questions about this algorithm, how to do this? And yes, this is ODP 450. Tomorrow's ODP 452 will have you remove just the first occurrence of the letter X. That's a slightly harder problem. But for now, we're going to remove all the X's. And play around with this on paper. Play around with some edge cases. What if your input string is empty? What if it's just, a string of length 0? What if your input string only contains uppercase X's? What if the first letter is an X or the last letter is an X? What if there are no X's anywhere in the string? Those are all good edge cases to think about in terms of the algorithm, right? And writing code and trying it is not necessarily as insightful as working through the pseudocode on paper. If you really want to understand an algorithm, exercise it on paper. And then when you're pretty sure it works, code it up, throw a zillion test cases at it, make sure those all work, and then go ahead and assess it. So you can use string copy and string length, no other functions unless you write them yourself. So don't throw a regex parser at this or something like that, right? Don't run it through sed. String copy and string length. And make sure your program doesn't read any input, doesn't produce any output. Okay, it's just a silent function. And then I suggest put your clean function in a file called clean.c. Make sure there's no main in there. And then when you're ready, compile it with the test bed as usual, gcc-o, odp450, name of your file containing clean, and then the testbed.o. And then assess it in the usual way. Assess executable name, source code file. And this is an all or nothing. There's one set of tests and you get 0 or 10 out of 10. So really think about edge cases. Empty strings containing nothing but X's, containing no X's. X in the beginning, X at the end, X in the middle. Multiple X's next to each other. And make sure you've tried all of these. Alright, let's play with some code. So passing strings to functions, changing them inside functions, passing them back, and so on. All right, so we're just going to play with a sample function called myFunction, and I'm declaring it the way that we said to prototype the clean function, which is return no value, so declare it as void, and don't do that as void star, just do it as void, and take one argument, which is a char star, so character array, a string, a pointer to a character, whatever you like. So that's the function prototype. Okay. When I call fgets, I'm going to try to read from standard in and save in an array called temp. So here I need to actually set space aside for 120 characters, and I need to make sure temp points to that space. So if I were to say char star temp, that's not going to do any of those things. Okay, what I need to do here is say char temp bracket 120. And that's allocating space in memory and then causing temp to point to that space. So now temp is an array of 120 spots in memory, and when I say fgets into temp, that should work fine. And when I call myfunc and I pass it temp, I'm going to pass the address of that chunk of memory to myfunc. So down here in myfunc, what am I going to do? I'm going to declare my argument to be char star. That's okay because the value of arg will be temp. That's what happens when we pass variables to functions. When myfunc starts executing, the value of arg will be temp. And since temp points to a block of 120 locations in memory, and temp should be the address where the user's input is stored, right? Arg will be all of those things also. So I can do what I want with arg down here. Well, let's just do a really simple function. Let's just truncate argument to 4 characters. All right, just to show that we can modify the string and the modification takes. So if we want 4 characters in our string, that means I want my null terminator right here. Well, this is index 0, 1, 2, 3, index 4. So if I stick a null terminator in index 4, that should terminate our string to 4 characters. So I'm just going to do that. I'm going to say arg bracket 4 equals null terminator. That's just a random thing to do. All right. And I wouldn't want to do this if I didn't know something about arg. Like I didn't know that it was 120 characters. But we're just playing around here. All right. So let's compile this and run it. So if I say hello, it comes back, and after calling myfunc, temp is HELL. Right? And this is let's do a before and after. Right? So inside main, myfunc was originally 6 characters long, HELLO followed by a new line. After I called myfunc, temp got changed, and that was equal to HELL. And if I put in 3 characters, it comes back, and after calling myfunc, my string is what it was before I called, ABC followed by a new line. All right. So myfunc itself is useless, right? It's just an example of passing strings. Now something to be careful of. If I try to call myfunc with ha ha ha, I get a seg fault. Why am I getting a seg fault? Because my func is trying to change the argument itself. And when you declare a string by saying double quote such and such, it goes into a protected area of memory, an area that you can read from but not modify. And my func is trying to modify this variable in a protected area of memory, and I get a seg fault. So you got to be a little careful when you're testing this. You can't necessarily just hardwire code together like this. But what you can do is something like this. So I'll mark that as a seg fault. But what I could do is copy from ha 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 into a local variable like temp, and then call my function, and that'll work fine. Didn't print anything because I didn't tell it to print anything, but if you want to write test code and pass a bunch of strings, string copy can be your friend there too. Alright, that's everything there is to know about ODP 450. Questions on that? We got 8 seconds left. Alright, I have faith that everybody knows what to do for ODP 450. So rock on with that. I will see you next time. Thanks.